this is the plan for this topic. First, I will give you the introduction. After that, we will see different types of oscillators. How can we construct the circuit for each category? So we will see RC, phase shift oscillator, Wien bridge oscillator, crystal oscillator, and finally we will see LC oscillators. These all are based on RC, resistors and capacitors, and this one is LC, inductor and capacitor. So Hartley and Colpitts oscillators. These are the major classifications of oscillators in the field. The purpose of this lecture is to introduce basics of oscillators and its basic circuit design. First, what is an oscillator? So oscillator means something that creates oscillations. Oscillations mean, okay, so it's something that creates oscillations. What is oscillations? Oscillation is just a technical term for something moving back and forth. So for example, in the olden days, we have a clock, the big wall clock. So in the wall clock, the center part will just move left and right, left and right. That is also called oscillations. So oscillations can be anything. So that is moving back and forth. For example, we will see one simple analogy. If you have a swing and which is moving back and forth, then you can say that swing is oscillating. So something is moving back and forth. Okay, this is just one simple analogy for you to understand this word oscillation. So it's just like it's a fancy word, oscillation, but it's just indicating something which is moving back and forth. So in the context of electrical engineering, because we are engineers, so we are always talking the topics with respect to electrical engineering. So here, what is oscillator, or what is an oscillator, or what is an oscillation? So here the oscillations that we care about are voltages which are moving back and forth. For example, here is a sine wave. So that is oscillating from plus 1 volt to minus 1 volt back and forth. So this is the AC voltage, right? So this is the AC signal. So the signal is now in the positive side, and then it moves to the negative side. And then it will go back again to this positive side, and then it will go back to the negative side. Back and forth, back and forth, back and forth moving. So this is called oscillation. Okay, so now you know the definition, or at least the meaning of oscillation. So whatever the system or circuit that performs oscillations, we can call that as an oscillator. Okay, an oscillator is a circuit that would generate a repetitive back and forth, back and forth. It's a repetitive. Repeatedly it's happening. So, okay, back and forth waveform that is called as an oscillator. So oscillators can generate either sinusoidal waves. This is the sinusoidal wave, or non-sinusoidal waves. Non-sinusoidal means whatever the waveform which are not in this shape, that is called non-sinusoidal waves. For example, square wave, it can be a square wave, or it can be a triangular wave, and so on. So that is oscillator. So oscillator is a circuit that would generate a repetitive back and forth waveform. It can be either sinusoidal or non-sinusoidal. So now you can ask me, or you may think about, what is the use of oscillators? So oscillators are used all the time in electronic designs. It's one of the very important circuit or part of the electronic designs. For example, it can be used to generate audio and radio frequencies. And it can be also used to generate signals for counters to keep track of time. It can be also used to generate clock signals to control the speed of digital signal processors. So where we use these digital signal processors, we are using in our smartphones, in our computers. So in so many applications, we are using these digital signal processors. So for example, we can talk about this microprocessor or microcontroller, right? Microcontroller means we have an embedded memory. Microprocessor doesn't have an embedded memory. So it can perform, so what is inside the microprocessor? There is a ALU, arithmetic and logic unit. So it can perform addition operation, multiplication, division, comparison. So it can perform so many different types of arithmetic operations. So inside the microprocessor, we have everything in terms, if you draw in terms of block diagrams, this is going to be an adder, and this is going to be a multiplier. And of course, there will be some registers temporarily to store the data while processing the data. And here we have to move the data from the registers to the adder, and the adder will add the data. Maybe it takes data from another register and it's adding the data, and then it will send the result to the external world, right? So we need kind of synchronization between these blocks. So I am taking the data A, and then after that I am taking the data B, and then I am adding, and then I get the result, maybe result is equal to Y, and I am sending this outside to the output pin of the microcontroller or microprocessor. So of course we are processing all the signals in terms of zeros and ones. That is the binary data inside the microprocessor. That is why we are getting zeros and ones from the registers and then adding them. And then, okay, so where we are using oscillators? Remember, we are always performing these operations with respect to clock signals. So master clock, either clock signal is what? These are the clock signals. So we have the rising edge in the clock and we have the falling edge in the clock. So this is called off time. This one is 0 and this is called on time. This upper part, this is the on time. If you add on time and off time, then that is called a duty cycle. So for example, if you program this microprocessor, it can only take the data at the rising edge. So whenever the clock signal, when it rises, then it will take the data from this register and then it will start to process. Or you can also program, it can take the data only at the falling edge of the clock. So we are having clock signals to make the synchronization between different blocks inside the digital signal processors. That can be a microcontroller or microprocessor. Okay, so this clock signal, where do we get this clock signal? Oscillators are the one generating these clock signals. So we are using oscillators inside this microprocessor. So this generally we are using kind of crystal oscillators to generate the clock signals because it has a low cost and it's easy to implement. Okay, so the oscillators are very important in most of the electronic designs used to generate clock signals to perform the synchronization between different blocks. Our smartphones definitely have the oscillators. Our computers are also having oscillators. Even in the lab, you have the oscillator, oscilloscope, which is generating frequencies and so on. So you can generate either non-sinusoidal or sinusoidal waveforms. So oscillators are basic and important circuit in electronic designs. So now we will see what are different oscillators available and how can we design an oscillator, because that is important part, because you are in this course electronics, especially in this section. So we are only going to see what are the available oscillators in the industry and how can you design one oscillator?